So in this lab, calculating the diversity of trail mix, we're looking for a quantitative value of the diversity, the richness and the evenness, and then what the diversity of it is. And we're going to be using Shannon's index. And Shannon's index follows this particular formula, which H is going to be the Shannon's index value. This is the sum of all of the different individual species, the proportion of individuals found within the community, the natural logarithm of those species, and then you're going to add that up to get the number of species in the community. So it doesn't really fit really well into this particular formula. So it's a lot better to use a chart when actually using Shannon's index. And there are lots of websites that you can go to use those charts, but you have one on your lab sheet. So looking at the lab sheet, okay, in the lab, we got two containers of trail mix. One would be community A, and the other would be community B. So we have community A and community B here. So you can see these, community A and community B. And what we did is we're just counting these in those communities. So in here we had on our particular site, or on our, sheet, we had, we're going to be looking at the different organisms. So we had peanuts. There's all my little peanuts right here. Okay, so I had, you can be writing in here peanuts. Then we had M&Ms. And we are looking at the, even though there's different colors, of course we're going to look at that as though that's different genetic variations within that species. These are going to have different sizes, different colors, as we go through. When you're counting, this may be a whole. Don't count that as a half. It's actually still a whole. Think of it as maybe a juvenile or an adult, or just count the different individual pieces, even though they may be stuck together still as wholes. If they're broken, that's still one, okay? So we have our peanuts, M&Ms, almonds, cashews, and raisins, okay? And so you're just counting the number of species. So I've actually counted these. And in our community A, we have, in community A, we have, for our peanuts, we have 35 peanuts, 11 M&Ms, 1 almond, 5 cashews, 27 raisins. And when we add all that up, means we have 79 organisms within community A. And then we'll do the same thing for community B. But let me show you what we are going to be doing next to do the calculations for Shannon's index. Okay? So it has pretty much the directions right on the sheet for you. So we're looking at, here is the I, the individual, the number of species in the sample. So we have the I. So we're looking for what is the proportion of individuals found within the species. So here we would be going 35 divided by 79, 11 divided by 79, because that's the total number, 1 divided by 79, 5 divided by 79, 27 divided by 79, and so on. So I'll just stop here for just a minute and let you run through and do those calculations. When you add all of these up, we're going to go to these 2 decimal places, just 2 decimal places. So it should add up to be, close to 1, right? Close to 1. And so I'm going to stop and give you a chance to find out your proportions there. Okay, so we've done our proportions, so we have them to the second decimal, and if I added these up, they actually end up being 0.99 something something something, so it ends up being 0.99. The second part we're going to do is we're looking for the natural logarithm of this particular number, so we're going to be the natural logarithm. It's in French, it would be the logarithm national. So that's why they have LN, but here in the United States, we don't put our adjectives before, we put our adjectives and things before the nouns. So we would have, natural logarithm is what we would call it. So if you're looking at your calculator, you have the natural logarithm here. So you would say the natural logarithm of 0.44 equals, and that would be negative 0.82, okay? And then we would have the natural logarithm of 0.14 is going to be negative 1.97, because we're going to round up to 2 decimal places, okay? And we'll continue on with the natural logarithm of 0.01 equals negative 4.61. I am rounding up. Again, the natural logarithm of 0.06. Natural logarithm of 0.06. Negative 2.81. Natural logarithm of 0.39. It's going to be 0.94. Okay? So then what you're doing there is you're going to continue on and just using your charts. It tells you the instructions. We are continuing on to find, we're going to take the proportional number, the proportion of individuals, and we're going to multiply that by the natural logarithm of the proportion of individuals. And it says here to add this column and remove the negatives. So if it's just as easy to do, go 0.44 times 0.82 equals, because you're going to take the negatives out anyway, it would be 0.36, 0.14 times 1.97, 0.28, okay, 0.01 times 4.61 equals 0.05, 0.06 times 2.81 equals 0.17, and the last one, 0.39 times 0.94 equals, and we have 0.37. So it says to add the column and remove the negatives. Well, we've already removed the negatives, so let's go ahead and add the column. 0.36 plus 0.28 plus 0.05 plus 0.17 plus 0.37 equals, and that's 1.23. Okay, so that's community A, and we need to do community B. And in yours, you need to look at the data for community B. We have our peanuts, M&Ms, almonds, cashews, and raisins. So here's the number of each individual species, and when we add those up, we get a total number of organisms within the community of 79 again, oddly enough. And then you can actually begin to do the math like we did before to find the proportion of the individual in that species, the natural logarithm of that proportion, and then the multiplication of the proportion times the natural logarithm to find what your H is going to be here. Okay? After determining the H of the value for each community, which one is the most diverse? Well, you can look at, it's typically between 0 and 5, or many of Shannon Weiner's indexes come out between 1.5 and 3.5. Very rarely do they get up to being 4.5, but of course there are some that are less than 1.5. So the range is actually 0 to 5 in some areas. And that diversity index measures the degree of uncertainty in a community and has two parameters, the richness and then the species abundance. So we were looking at this richness, which is the species abundance, and then we have the evenness, which is kind of like the, the equivalent of, or if you calculate the equitability of the particular community. We talked about richness and evenness last week in class with our notes. So you'll want to be able to calculate for community A and community B to be able to find out what your evenness is, what your richness is, and then what your H is. So considering all three of Shannon's measurements, H, which is here, S, which is here, and E, which is going to be, your evenness, which community is most diverse, explaining your reasoning. So you're looking at, this will give you a better understanding to obtain some H values. And if E is close to 1, this means the equitability is higher. All species or community are represented by a similar number of individuals. I don't think we're going to find that here because we have a very varied number in there. So we'll be looking at the H, the evenness, and the S, and then you'll be actually solving for the diversity there with that. And then the last two questions are, what are two advantages of using Shannon's index rather than simply using an overall population count? And then what are two disadvantages of using Shannon's index? Now you got to stop and think. These are in our trail mix. Our trail mix isn't moving. It isn't coming in and going out throughout the day as we're measuring for this particular time. They're all pretty sedentary right where they are. So think about what might happen in nature and use some logic of how that might change what your advantages or disadvantages are in using Shannon's index. Okay, there is a video on Shannon's index, so if you wanted to know more about that, or if you're wondering about calculating and this has not helped, then there is another video that's on there, and I will post this one as well. So there is your data to finish the lab, and make sure you upload that into Canvas.